Good morning to one and all. My name is Krishna Mohan, working as an assistant professor in Computer Science Department, AIML. Today, I am going to discuss what is design of control unit. Design of control unit comes under Unit 4 of CSA subject. So, the design of control unit is categorized into two parts. One is hardwired control unit and the second one is microprogrammed control unit. So we can execute the instruction using hardwired control unit and microprogrammed control unit. If we go and execute the instruction in hardwired control unit, what is the procedure we are going to follow and what are the instructions to be followed that we see in hardwired control unit. Next, if we go to microprogrammed control, we see how the programs are, how the instructions are executed in microprogrammed control. So what makes the difference between this hardwired control unit and microprogrammed control unit, and what is the base architecture if I execute the instructions in hardware, and how to execute or how to use an architecture in microprogrammed control unit. So we make the differences between these two and see how the working nature or how the instruction is executed. By taking an example, we'll try to see how the instruction will be executed. First, if we go to hardwired control unit is a control unit that uses a fixed set of logic gates and circuits, to execute an instruction. Fixed set of logic gates means we are using the hardware components to execute the instruction. Simply, if I want to execute an instruction, suppose R tends to R1 plus R2. Suppose if I want to execute this instruction, that is, I have a content in R1 and I have a content in R2, where I am going to add these two instructions. And after getting the result, I am going to store in the another register. So if I want to execute this operation, the operation should be carried out by using a hardware control unit or a microprogrammed control unit. So if I go with the hardware control unit, how to execute this R tends to R1 plus R2. So for this, we are using a set of logic gates and circuits. These set of logic gates and circuits will try to accommodate the instructions given by the register R1 and the instructions given by the register R2. Immediately, once if the data is accumulated into the registers, the next thing is they have to execute the operation. So what operation is going to be executed? The operation to be executed here is an addition operation. So immediately the instructions will be stored or will be transferred to the ALU, where the ALU will try to decide which is an arithmetic operation, or it comes under logical operation, or it comes under shift micro operation. Immediately, once if the instructions are decided, where the instructions are coming under addition operation, the addition operation is implemented on the registers. So to implement this addition operation on the registers, the logic gates are implemented and the circuits are implemented. Right. Once if the instruction is completed, and once again if I am going to execute an instruction R2 plus R dash. So if you want to execute this instruction, there is a chance that the given instructions or the logic gates may or may not support. Because these are hardware components, these instructions are executed by using hardware components. Maybe the logic gates may or may not support. So immediately what I should do is I should try to change the circuits, or I should try to change the gates where these instructions are to be accommodated onto this particular logic gate and circuits. So likewise, I should try to change the logic gates or the logic circuits whenever I change the instructions. So this is a tedious process, but if I implement this particular logic gates or the logic circuits when I am executing the hardware components, the process is somewhat difficult, but the result execution is very fast. The execution of the result will be very fast if I execute the instruction by using hardwired control unit. The hardware control units are simple and fast, and they can be inflexible and difficult to modify. Because if it is of a program, we can change, or immediately we can try to do some modifications, and I will try to make the implementation once again. But coming to the hardwired control unit, we cannot do any modifications, because if I want to do the modification, I have to change the circuit. If I want to change the circuit, immediately I should try to replace that with the configuration, or I should replace that with high end or low end of the circuit. So for doing all this, the process may be difficult, or the process may be somewhat tedious to follow, but the execution, once if it starts, the execution speed is very much fast when we compare with that with the software or the programmed control unit. So hardware control is faster than microprogrammed control unit. So first difference we can say between the hardwired control unit and microprogrammed control unit is the instruction execution is very much fast when I compare that with the microprogrammed control unit. Next, if you see the block diagram of hardwired control unit, how the block diagram represents, if you see the diagram where we see an IR, instruction register. In the previous class, we have seen what are the different types of registers we are having. So there are 7 types of registers. Among those 7 types of registers, we use instruction register, which plays a very critical role, where it is trying to accommodate n number of bits which are to be represented in the instruction register. So if I go with the 16-bit register, first 12 bits will be for the address or the data storage. Next 3 bits will be for the opcode, and finally 1 will be for the change of the code of the indirect or direct addressing. Direct or addressing mode or indirect addressing mode is the last bit which is going to take the change. The other 3 will be taken as the opcode. So which operation to be executed? The opcode occupies 3 bits, where these 3 bits will try to indicate which operation is going to be performed on the given data or on the given set of instructions. Right? See, these 3 instructions are included with or dedicated with the 3x8 decoder. And finally, if you see 4x16 register or 4x16 decoder, and other things we see here, the clock, a clearance cell, and the increment cell. So all these are connected to the control logic gate. So all these registers are control logic gates, where the control logic gates will try to take the inputs. What is the role played by the control logic? It tries to take the inputs which are given by the registers. If you see here the instruction register 0 to 11 is going to give the data as an input. The instruction register will try to give the data as an input, where the input is processed in the control logic gate. Next, so when we go with the instruction register, we specifically tell the 3 bits are occupied by the opcode. The opcode is also one type of input, where it tells which operation is going to be performed on the given instructions. So the given instructions may be an addition operation or a subtraction operation or a multiplication operation, where these instructions are carried out by the opcode. Finally, in the 15th bit register, if you see, I will see an I. So that is indirect or direct addressing mode. That occupies the input as a indirect addressing mode. Next, finally, if we see the decoder 4x16, the 4x16 decoder will be trying to make the adjustments which are given by the input from the instruction register. So all these inputs are taken by the control logic gate, where the control logic gate will try to process all the instructions and try to give the output. Right? So in this way, we can see how the design of hardware control unit is done. So how to design a hardware control unit? Once if the designing of hardware control unit is done, next we will see the working of hardware control unit. Because once if the design is done, then we can go for the working, or we can say it as the implementation of the instructions when we apply them on the hardware control unit. Suppose if I want to execute the instruction, the thing is you should have some architecture, or it should have some design. So basing on the design, we can execute all these instructions. Coming to the design of hardware control unit, see, we have the following constructions of hardware control unit, where we have followed three methods for the designing of the hardware control unit. The first method we'll call it as a sequence counter method. So one of the method which we follow for designing of hardware control unit is sequence of control method. Next one is a delay element method. The second method which we follow for designing of hardware control unit is delay of the element method. The third one is state table method. The state table method is the third method which is used for implementing the hardware control. Now we'll see how this sequence, delay and state are implemented for designing the hardware control unit. Once if we go with the sequence counter method, it is the most practical way to design somewhat complex controllers. Suppose if you have some complex controllers, where these controllers will be difficult to implement them in the hardware control unit. So to implement this hardware or the complex methods, we use the sequence counter method. Sequence counter method is SC. SC is equal to SC plus 1, where we are trying to increment the instruction from one register to another register or from one register to another register. Next, delay element method for creating the sequence of signals. This method relies on the usage of time delay elements. Suppose if it is taking an instruction some half second to execute the instruction. Once if the execution speed or once if the execution of this instruction is getting delayed, so it tries to give a signal saying that the particular instruction is going to take some more time for the execution. So it will take it as 1 minute or one more complete second to execute the instruction. So that instruction is implemented or this instruction is intimated by telling the delay element method. Next, state table method. The state table method indicates the node controller utilizing the classic table used in this particular method. The designing of the classic table, state in the sense in which position it is. In which position it is, the instruction will be indicated by the state table method. Now, if you go to the working of the hardware control unit, the hardware control unit is the basic data for control creation and also the operation code of the instruction, where the basic thing which we have to see while we are trying to execute the hardware control unit is, once the control unit is implemented, the control logic gates will work. The control logic gates are working on the control implementation of the given hardware control unit by giving the input. How the working of hardware control unit is going to be done, we'll see. So in the previous slide, we have seen how to design. We are designing that by using three methods. Once if the designing is done by using the three methods, immediately we should try to make the working or the implementation of the hardware control unit. The first point, the hardware control unit consists of two decoders. See, if you go to the back and if you try to see how the hardware logic is implemented, we'll see here 3x8 two decoders. That is 4x4 decoder and another one is 3x8 decoders. And we see another sequence counter for that particular hardware components and another one is number of logic gates. So in the first step, we find the hardware control consists of decoders, sequence counter and the number of logic gates. These three are very important if you go and execute an instruction in hardwired control unit. One is decoders, the another one is sequence counter and the other one is the number of logic gates required. Second point, if we see an instruction fetched from the memory unit is placed in the instruction register. So where we are getting the memory, from where we are getting the instruction, that is whenever we are giving an input, the input is carried out into the memory unit. So once if the memory unit takes care of this particular instruction, it stores in the memory unit in some particular address. Once after storing the data in the particular address, it immediately transfers that instruction into the instruction register, where the instruction register will try to execute these instructions. How it is executing? It is trying to execute one initially by storing that in the address space, that is 0 to 11 bits. The 0 to 11 bits are occupied by the data. Next, 0 to 11, it is occupied by the address and the data. The next 3 bits are stored for the opcode. the opcode will try to give the which operation to be performed on the register data. Suppose if I am going to send some n number of bits into the instruction register, these instruction registers should have some operation where that operation is carried out by the opcode. Next, the component of an instruction register include one bit, that is the operation bits is through 0 and 11. The operation code bits will be from 2 to 14. As we discussed, the operation code will be done between 12 to 14, means 3 bits it occupies. Next, the output of the decoder are designated by the symbol. The output of the decoders means if I am going to execute 3 by 8 decoder and if I am going to execute 4 by 16 decoder, all the indications of the outputs are done from D0 to D7. D0, D1, D2, D3, D4, D5, D6 and D7. Next, the opcode of a bit is transferred from a flip-flop designated by a symbol I. The flip-flop indicates 0 or 1. Yes or no? The flip-flop indicates 0 or 1, where that indicates if I say it as I or O, indirect or direct addressing. Next, the sequence counter can count the binary bits from 0 to 15. The sequence counter, where it tries to increment its sequence counter registers by incrementing with 1. SC is equal to SC plus 1. Suppose I have some 16 bits. The 16 bits to be counted in a instruction register is done by the sequence counter, where the sequence counter will try to count all the bits in that particular instruction register by incrementing the sequence counter, where we can say SC is equal to SC plus 1. Suppose if it is in the 0 bit, that is 0 plus 1 first register it is occupying. Next, once if the instruction is stored, immediately it increments 1 plus 1, where it becomes 2. Likewise, it tries to execute or it tries to add the instructions 1 to 1 and places that in the instruction register. So that is the role played by the sequence counter. So finally, we can say the hardware control unit mainly depends on the decoders, that is 3 by 8 decoder and a 4 by 16 decoder. First thing, and after that, the instruction register IR plays a very important role, where in the IR also it categorizes the data or the address register, and next it tries to implement the opcode, and finally it indicates. And after that, it goes to the sequence counter, where the sequence counter will give the count of the bits in the register. And finally, all these are linked as an input to the control logic gate, where the logic gate will implement and execute the instruction and throws the output to the instruction register. Next. So this is the process we follow when we go with the hardwired control unit. See, whenever we get a problem in the hardwired control unit, it is very difficult to change the instruction immediately. Why? Because we are operating the complete hardwired control unit by the circuits. So if you are getting a problem, or if that particular circuit is not able to give a place to the instruction register to be added newly, immediately we should try to replace the component. So it is becoming somewhat tough task to do the execution of instructions by using hardwired control unit. So what is an alternate for that? Is there any alternate to make a replacement of hardwired control unit? Yes. We have another replacement for making of or for executing of an instruction other than hardware. We have an alternate which is called as a microprogrammed control unit. No doubt, here also we are trying to execute the instruction only. If you go and execute the instruction in hardware, or if you execute the instruction in microprogrammed, both are one and the same. Only the thing is the process gets changed. In hardware, we are using the hardware components and the logic circuits for the implementation of the instruction or execution of the instruction. Coming to the microprogrammed control unit, we are not using any type of hardware components or circuits or logic gates. Simply, we use a microprogram or a program where we can read and write the program and try to do the modifications for the execution of the instructions. Now we'll see how this microprogrammed control unit differs from hardwired control unit for the execution of instruction. The microprogrammed control unit is a unit that stores binary control values as the words in the memory. So if you execute an instruction in a microprogrammed control unit, first initially it stores the binary control values in the form of words. Words are nothing but the collection of bits. If I say it as a word, means it have some n number of bits where these bits can store the information or the set of instructions to be executed will be stored in the bits. So the collection of bits we are going to consider it as a word. Right. Next, the MCU's control memory stores a microprogram made up of micro instructions. The MCU's control memory stores a microprogram. See, the instructions what we are going to write here is considered as a microprogram. Whatever instructions we want to execute, if we are writing those instructions are considered as microprogram or microprogrammed control. The main difference between microprogrammed structures and the hardware control unit structure is existence of control store. The existence of control store plays a very important role when you compare the hardwired control unit with the microprogrammed control unit. Hardware control units are usually faster. As we discussed in hardware control unit, the hardware control unit instructions are very much fast when you compare that with the microprogrammed control unit. The microprogrammed control units are a relatively simple logic circuits, very simple logic circuits where we can try to implement or where we can try to do the changes to the micro instructions whenever required. And once if the instructions are changed immediately, we can try to execute those instructions also very fastly when we compare that with the hardware. Right. See, if we see here, we will see the structure or the design of the microprogrammed control unit. If I want to execute an instruction, how it is passing phase by phase to execute and use the result when compared with the hardware control unit. See here, we are giving an external input. If you see the diagram here, the external input we are giving. The external input is carried out into the next address generator or the sequencer. The sequencer role is, so both we have the sequencers in hardware and in a microprogram. The sequencers will try to make an increment or will try to store the data or will try to make the address generation. Suppose I have an address 100. If I am storing some instruction here, immediately if the instruction is executed or stored in this 101, the control should be transferred to the next address which is 100. So that is the role played by the sequence counter when it is going to execute microprogram instructions in this particular memory. From there, the address is transferred to CAR. We'll call it as control address register. Once if the data is stored in the sequence counter, immediately it is transferred to control address register, that is CAR. From there it is transferred to control memory, which is ROM, and from there it is transferred to control data register. So after the block diagram, we will try to see what are the characteristics of microprogrammed control. First one, the micro instruction address is specified in the control memory address register. Control memory address register. Next, all the control information is saved in the control memory. Whatever you are trying to store, the data, it is stored in the control memory. So which is considered as RAM. So if you go with the RAM, the data will be stored in the RAM only till the system is closed or till the power is off. Next, the micro instruction received from the memory is stored in the control register. The micro instruction received from the memory is stored in the control register, because the control register plays a very important role in storing the instructions and also the execution of the instructions. Now we'll see what is this control word. So I told you control word is a collection of bits. So whatever bits we are trying to find in the instruction register, those bits are stored in the control word, or we'll call it as word, which is collection of bits. Specifies one or more multiple operations for a data processor. Next, the next address is calculated in the circuit of next address generation and then transferred to the control data register. Once if the address is generated or once if the address is finalized, immediately it is transferred to control address register, where we find next micro instructions. Because it determines the sequence of addresses received from the control memory, the next address generator is also known as microprogrammed sequence. Right, so that we find or that we'll try to see the difference where whenever we compare with the hardwired and microprogrammed control. Right, next we see how the memory hierarchy. The memory hierarchy plays a very important role where the data is to be stored in the computers. So memory hierarchy is one of the most required things in the computer memory. So it is very critical whatever data we are going to store or whatever data is given as an input, or once if the data is processed, everything should be stored in the memory. So that we will call it as a computer memory, and it helps optimizing the memory available in the computer. There are multiple levels present in the memory, each having a different sizes and different costs. Now we'll see what are the basic types of memories available in a given computer. So if we say types of memories, one will call it as external memory or secondary memory. First one will consider it as external memory or secondary memory, where this external memory or secondary memory comprising of the magnetic disk, optical disk, magnetic tapes and other external sources which are used for storing of the data. Externally, when we are trying to use some component and we are trying to store the data, so that type of component have different names and different sizes and different charges are to be levied, where we can get the components and use that for attaching it to the computer. So if you are trying to execute such type of data and memory storage, that we will call it as external memory. Next, if you go to the internal memory or primary memory, comprising of main memory or cache memory. Main memory is considered to be as an important memory for a computer. Main memory is important memory for a computer, where this is considered as internal memory, or we will consider it as a primary memory. So by differentiating with external memory and internal memory, we will try to see what are the different types of memories we have. So where these memories are considered as level wise, that is level 0, level 1, level 2, level 3. Suppose if we say it as level 0, what the memory hierarchy or what the data is considered. So that is considered as CPU and registers. In the first level or in the 0 level, we will consider the memory as CPU registers. In the level 1, we will consider it as cache memory, or we'll call them as SRAMs. Cache memory is the fastest memory where we can execute the instructions compared to the general memory also. In the level 2, we find main memory. In the main memory, we will find DRAMs. So by using the DRAMs, we use to construct the main memory. And level 3, we will consider it as a magnetic disk or disk storage, where we will consider it as external storage also. So if we see the previous slide, in the external memory, we have shown it as secondary memory. This we will consider it as the secondary memory or the external memory. So that comes under level 3. Coming to the optical disk and the magnetic tape, these two comes under level 4. So in the next session, we'll try to discuss how the memory hierarchy is classified and how each and every memory is working and how they are going to store the information. So what categorizes the external memory? So that we'll see. And what categories are there in the internal memory? That we see by using the pyramid, where this pyramid indicates the levels from 0 to level 4. So in detailed discussion, we'll see on registers, the cache memory, main memory and virtual memory in the coming next sessions. Thank you.